Good morning, everybody. Today's lesson is on factoring using a greatest common factor. We're going to use the letters GCF, standing for greatest common factor. Might ring a bell from back in 4th and 5th grade, but we're going to be doing it more in a high school context now. So, factoring is basically the reverse of multiplying. So you've already learned how to distribute. That was what we did earlier in the week. What we're doing now is we are undistributing. We're distributing backwards. So what you need to do on these types of problems is look to see what this term and this term both share, or what they have in common. What they have in common is called the GCF. So through multiple examples, we're going to do 4. You should see that. Anyway, here can you see that this term and this term both have a 5 in common? So 5 is what's going to be written out in front. Now we need to have a single set of parentheses, and we can see that there's a minus sign in the middle. So I'm going to go ahead and put the minus sign in the middle. And now you're thinking to yourself, 5 times what gives me 5x? Hopefully you can see the answer to that question is simply x. And now you ask yourself the same question, 5 times what gives me 5y? Hopefully you can see the answer to that question is y. So this is our response. This is the factored form of this expression. Notice if I were to distribute the 5 to both the x and to the negative y, I would get with what I started with, yes? So that's a way to check to see if your answer is right, but this is the answer to a factoring question like this. Okay, so example 3, very similar. We're looking to see what 14 and 76 have in common. Sometimes doing some notes to yourself will be helpful. 14 is the same thing as 7 times 2. 63 is the same thing as 7 times 9. So when I write it this way, you can see that both of these numbers have a 7 in common. So that's my GCF. I'm going to pull out a 7. And now I'm going to open up parentheses, and now I'm going to fill in the blanks just like in the problem before. So 7 times what gives us 14? Hopefully you can see the answer to that question is 2. But 7 times 2 doesn't give me 14x. So hopefully you can see that this 2 needs to have an x next to it. Now 7 times 2x does give me 14x. That's good. So now 7 times what gives me 63? If you look at our notes up here, you can see that number is 9. So therefore, 9 needs to be inside of the parentheses. It's always good to check and see if this term and this term have any common factors. Okay, example 3. Example 3 is 8 minus 24x. I want to show you an incorrect result that many students give so that you can learn from it, and maybe it will save you some headache and heartache. A lot of students will see, oh, 2 is a common factor, and they'll pull out a 2. And then they will write 4 minus 12x. This actually isn't bad, but this factorization is not complete. I can see this because this 4 and this 12 still have a common factor. So the mistake that the student made was they pulled out a common factor, but they didn't pull out the greatest common factor. So that's a problem where you might get partial credit. Can you think of a number that goes into 4 that also goes into 12? Well, that number should be 4. 4 goes into both of these numbers. So I'm going to leave the 2 where it is, but now I'm also going to pull out a 4, because I can pull out a 4 because it's the GCF of these two terms. 4 times what number gives us 4? The answer to that question is 1. And then minus 4 times what gives us 12? That answer is 3. And so you can see I'm left with a 1 minus 3x inside the parentheses. Now let's not leave our final answer this way. What's 2 times 4? 8. So I'm going to write my final answer as 8 parentheses 1 minus 3x. I'm hoping that with some experience, you're going to be able to go from here to here in one step. Okay, so the last example for factoring via a common factor. I'm looking to see what number goes into 6 it goes into 9, that also goes into 15. This is an even number, so you might think 2, but these numbers aren't divisible by 2, so the only number that goes into all 3 of these numbers is 3. So we know that 3 is part of our GCF. Now, these 3 terms have more in common than just a 3. Can you see that this example, each of these terms also have an x in common? So I need to pull out that x as well, otherwise I haven't factored out the greatest common factor. I've just pulled out a greatest common factor. I've just pulled out a common factor. So we want to pull out the 3x. So here we go. Hopefully you can sense that I need a bigger parentheses this time. There's going to be 3 terms inside. There's going to be a minus about there, there's going to be a plus about there, and now I have to fill in the blanks. So 3 times what number gives us 6? Well, that's simply 2. And I pulled out one x, and there's 3 here, so how many more x's would have to be there? The answer to that question is 2. So 2x to the second is our first term. If I multiply 3x times 2x squared, I do get 6x to the third. Now 3x times what gives us 9x to the second? Well, 3 times 3 gives us 9, so I need a 3 there. And x times x gives us x to the second, so there needs to be an x there. And now 3x times what gives us 15x? The answer to that question is 5. Okay, so you didn't do this in pre-algebra, okay? The last part of tonight's homework is going to be a little bit of pre-algebra work that's going to be important for what comes in a week or two. Anyway, evaluating expressions is an important part of pre-algebra, and I just want to do 4 quick examples. We're going to suppose that we have a is 6, b is 9, and c is -3. We're going to find the value of these 4 expressions. For c squared over a, I'm going to just make the substitution. The value of c is -3. So I want to put -3 in parentheses. It needs to be in parentheses. The a value is 6. So now we simplify this. We're finding the value of this expression. That's what it means to evaluate. Find the value of. So hopefully you can see that the root of the word evaluate means to find the value of. Okay, so it needs to be simplified all the way. This means -3 times -3, which is 9. And so now it looks like we have 9 over 6. But 9 over 6 does simplify. I'm going to divide both the top and bottom by 3. And so that should give us a final answer of 3 over 2. Okay, example 2. This time it's b squared minus c squared. B squared minus c squared gives us 9 squared minus -3 squared. Okay? I'm going to use equal signs to show equality. 9 to the second power is 81. Don't distribute the negative into the parentheses. You have to do the power first. So this is minus -3 times -3 is 9. And so our final answer needs to be 81 minus 9, which is 72, I think. I'm doing that mentally, but hopefully that number is indeed correct. 2 more and then we're done. -2b over c. So we're just plugging in numbers and seeing what we get. In this expression, I can see in the top I have -2, and now I'm simply plugging in the value of b, which is 9. And on the bottom we have c, which is -3. So hopefully this works out into something that's doable. The top expression is -2 times 9, which is -18. The bottom of this fraction is -3. And hopefully remember that a negative divided by a negative is a positive, right? So we know we're going to get a positive answer here. And now 3 goes into 18 how many times? Well, that would be 6. Okay, so last example, we have to evaluate b squared minus 4ac. This is called a monomial. It has one term. So you need to think of the 4ac part as being by itself. So I'm going to put a bracket around it so that you realize that all of these things are being multiplied. So to evaluate this expression, I'm taking 9 and I'm plugging it in for b. That gives me 9 to the second minus, and now I'm going to open up my bracket. And now be very careful with this monomial. We have the number 4. I'm multiplying that by a, which is 6. And I'm multiplying that by c, which is -3. So look at all the stuff getting multiplied together. It's very easy to not evaluate an expression like this correctly. So we need to take it one step at a time. Although we're almost done, 9 to the second power is 81 minus, now inside these brackets, let's take it one step at a time. 4 times 6 is 24. So now inside the brackets, I have 24 times -3. We have 2 steps left. This is 81 minus, and now if I multiply 24 times -3, that gives me -72. So this is tricky. We now have 81 minus a negative number. That's the same thing as 81 plus 72. So on this tricky example, we have to add 81 and 72 together, and I think that's 153. All right, so good luck on this assignment. Have a good day.